Hi everyone, I hope you're having a wonderful day. I just wanted to make a video on 7 key JavaScript concepts that I think every developer should know. Now I apologize a little bit for the clickbait title. I'm aware that not everyone will need to know these concepts. These are things that I've came across and find interesting enough that I've either used them in production or I'm aware that I'll probably need to use them at some point in the future. So without further ado, I'll get straight into it. The first one is the console object. So the first program that everyone writes is probably hello world, and to do that in JavaScript, it's console.log. But the console API has more than just log. It also includes console error, console warn, console.table, console.group, and console.time. And there's much more, and I'll include a link in the description to the documentation. But if we have a little look here, we can see the example of console table. So I have this array of objects called enemies, and I'm calling console.table on it. So if I just bring up the console for a second and show you how this looks, let me copy all this code, go to the console, just delete this. It nicely formats these objects in a tabular way. Now for this example, these are actually pretty well laid out and you can see fairly straightforward. It almost looks like a table itself. But if you have some really complex objects, this can be a nice way of visualizing them. Moving on as well, we also have console.trace. Now calling console.trace, it will effectively log in the stack trace where it's being called from. So if we look at this example, we have an outer function and we're calling it, and then we're calling an inner function, and then that inner function is calling console.trace. So if we execute this code, let me actually just clear this table. If we execute this code, it shows us the stack trace. So we can see that it's called from inner and then it's called from outer. Now this is actually really useful, especially if you're navigating an unfamiliar code base, because sometimes you'll want to find out how a function is actually getting executed, where is it being called from, and what functions were called to get to that point. And it can be really quite confusing sometimes. So the easiest way is either to use a debugger or to stick in a console.trace and see where that's actually getting called from. Moving on as well, there's also console.time and console.timeEnd. And these are really interesting, and I'll show you a quick little example here. So I have this function called isPrime, and it takes a number and returns true or false based on whether or not that number is prime. Now it's intentionally inefficient because I was trying to get a little bit of a delay for the timer. And we have this second function called timePrimeChecker that takes a number and times the amount of time it takes to determine whether it's a prime. So let's look at this, for example. I'm calling it with 9. I start console.time with a label is9 prime, and then I console log the function being called, and then the function executes, and then after that we end the timer. We end it with the same label, and if I just execute this and show you the result, let me didn't copyright. Let me paste it in. There we go. So it says is9 prime false, is9 prime, and this took 0.06 milliseconds to determine. Is 323 prime false, and this took 0.01 milliseconds. And then it says, is this large number prime, which I know to be true, and this took 126 milliseconds to determine. And this is really useful for just getting a sense of how long it's taking your code to execute. Like if this was part of a backend, REST API controller, it would start to raise some red flags for me. I'd start to look and say, okay, 126 milliseconds for an 8-digit prime, that's a little bit high. What would happen if it was a 9-digit prime or a 10-digit prime? And it just gives me a kind of starting point of starting to look into whether there's anything that can be done to make that more efficient. Anyway, moving on. I will close the console now. So the next thing I wanted to talk about was the toString function. Now everyone, or not everyone, but most people might be aware of this. I'm creating a little function called enemy and I'm using it as a constructor. So I'm calling it, and that'll produce an object that has a name property with Grisnak, and then it has an age property with 400. And then I'm overriding the string, or the toString function on the prototype chain, and I'm saying whenever toString is called, return Grisnak is 400 years old. And then if we call that, it returns the expected string. This is all pretty straightforward. You might be aware of it, you might not, doesn't really matter. The thing that I find interesting is that you can actually do this on functions. Now let's look at an example here. Okay, so we have this function const times by 10. It takes an x and it multiplies it by 10 and returns that. If we call it, it returns, if we call it with 10, it returns 100. That makes sense. If we call the toString method on it, it returns a string representation of the function, pretty much exactly as how we defined it. And because it's a string, we can now manipulate it. So we can do something quite strange by saying, give me the string and then replace 10 with 20. And now I have this string, which is effectively a function, except it's been replaced. It's replaced the 10 with 20. And now to turn this string back into a function, we can just evaluate it. So I've defined this new function times by 20 by getting the string of another function and manipulating that string and then converting it back into a function. So this is absolutely cursed. Please do not do this in production or in any serious code base. I just found this to be quite a curious thing that you can do a kind of cursed metaprogramming using JavaScript's toString and evaluation functions. But anyway, please don't do this. Moving on. So I wanted to talk a little bit about proxy objects. So let's define, what does proxy mean? It's a bit of a weird word, and Collins Dictionary defines it as a person authorized to act on behalf of someone else, aka an agent. Another way we could phrase this is maybe a middleman, somebody that sits in between you and a service. And then in computer programming, Wikipedia defines it as the proxy pattern as a software design pattern, and a proxy in its most general form is a class functioning as an interface to something else. So like we just said before, it's a middleman class interfacing to something else entirely. So let's think of a hypothetical example here. You want to create a user object, but there's some validation that you want to happen on the fields. So a name needs to be required for a user, and the name has to not be too long. And the same for the password. The password is required and it shouldn't be too long. So you can create this little, constructor function here that takes a name and a password and just does the validation manually. But there's a bit of a problem with this, because as we can see here, it returns the object like we're expecting, but immediately after you can start to manipulate this object and bypass the validation entirely. We can set the name to empty, we can set the age to -20, and we can set the password to empty. If we console log that again, the user object's been completely destroyed. To get around this, or to introduce a fix to this, we can use a proxy object that sits in front of our user object and defines how people can interact with it. So let me show you an example here. We have this object called user handler. I'll explain this in a second. And we have this other function, pretty much similar to the example before, called create user. And we're calling create user with Church of Turing as the name and an example password. So I'm creating a temp variable and I'm assigning it to a new proxy. If we look here, this is the object that the proxy is middlemaning for. So it's sitting in front of this, but because we're just creating a new object, it can be an empty object. But it doesn't have to be. This can be an object that already exists, or a function, or really anything. The user handler defines how we can interact with this underlying object. So the proxy will sit in front of this object, and according to the rules of the user handler, will allow us to interact with it. So I'll show you a more concrete example. Let's assign a name to this object. And then once we do this, it'll trigger the user handler. It'll trigger set in the user handler, and this is called a trap. I'll include some documentation that shows all the available traps that you can define. But if we look here, it calls set with target, prop, and value. Target is just the underlying object, prop is the property that we're trying to access, and value is what we're trying to assign to that property. So just moving on, we can see if prop equals name, which it does because we're trying to assign the name, it'll execute this if statement. So it'll say if there's not a value, well, there is a value, so we can skip over that. And if the value.length is greater than 30, well, it's less than that, so we can skip over. And now we're saying just assign it like normal. So that means that it's passed the validation and the name has been assigned like normal. And the same for the password. We're trying to set the password. We go up, it calls the set function, or the set trap, I guess we should call it. The property is password this time, it's not name. So it'll go down to this else if. It'll start executing this. We have included a password, so it passes this validation, and the length isn't too long, so it passes this validation. And now we just update it like normal. And we return this proxy. So if we log this proxy, it'll show us this underlying object where the password is example and the name is Church of Turing. But the interesting thing about this, and I'll show you it in the console, if I open this here, let me just clear the console. There we go. Oops. So if I copy this code, hopefully this works. Let me see. So I copy this code, and if we look at the user, let me try and make this a bit bigger. If I just call user, it shows that it's a proxy object, and this is the object that it's proxying for, if that makes sense. It's middlemaning for this object. And if we try and do something like user.name equals empty, it'll throw an error, and it'll say no, a name's required. Because it's calling this set function, it's executing if prop equals name, and then it's throwing an error here saying, oh no, they've actually not passed a valid name. Throw an error for this. Similarly, if we try and do user.password equals empty, it'll throw an error, or if we just make it too long, it'll throw an error saying password is too long. So this way we've actually put validation on how people can interact with this object, which is quite a neat concept. And it doesn't have to just be for set as well. Like the other example I have here is that if I want to console log the user password, all right, let me go up a little bit. I'll show the code. It'll execute get instead, and it'll say if they're trying to access the password, return hidden, because we don't want to show them, the password, for instance. And then I can show this here. I'll do user.password, and it'll return hidden. But that doesn't mean the underlying password is hidden. It just means the proxy won't let you see it, which is kind of an interesting concept. So it allows you to really strictly define how people can interact with objects. Anyway, I will close the console and move on from this example. The next thing I wanted to talk about were tagged template literals. With ES6, JavaScript introduced template literals. So back in the olden days, we had to create our variables, and then if we wanted to make a string out of them, we just had to append them to each other. So we had to say name is age years old. So we're taking the name, we're appending this string, we're appending this variable, we're appending this string. And this worked well enough, but it was a bit tedious when it came to including expressions or including multi-line strings, for instance. So with ES6, JavaScript introduced template literals, which use these backticks. And inside them, with the $sign and braces, we can now include variables, we can now include expressions. It's just a neater way of doing it. For more advanced functionality, though, we can use tagged template literals. So in this example, we have a function called sentence. Don't worry about it too much right now, just know that it's a function called sentence, and I'll explain it in a second. We're defining our variables again, so we're saying the name is Church of Turing, and the age is 200. So in here, we have this template literal like we had before, but we're tagging it with a function called sentence. And it's basically just calling the sentence function, passing this in, and doing a bit of destructuring. So I'll show you what I mean in a second. This calls the sentence function, and it passes in strings, which are kind of these text parts, and it passes in values, which are the kind of template value parts. So it splits these up for you. If we look at the console log, I'll show you what I mean. So I console log strings. The first one's empty because in this instance, the first string is a value. And then it says is, and then years old. And then if we look at the values, it shows the little values that were passed in the form of name and age. So the name was Church of Turing and the age was 200. Now something, if you've noticed or if you have a keen eye, you'll see that to create the string that we want, we basically have to interleave these arrays. We need to append this, or we need to take this and then append this string and then append this string. So it'll say Church of Turing is, and then we need to append this value, 200, and then we need to append this value. So you're kind of interleaving the arrays. And this is effectively what this function does. We take an empty string, we iterate through this strings array that's been defined up here. We get the current string, which in the first instance will be an empty string. We're appending two empty strings, which is an empty string. And then we're saying if the values array has an item at this index, which is 0, and it does, which is Church of Turing, then just append that to the results. So now results is a string with containing Church of Turing. We're iterating again, const cur equals strings I. Because I is equal to 1 now, it'll be this. We append this to the string, so we're saying Church of Turing, and then we've appended is to it. And then we do the values check again, because I is 1 now, it'll see, oh, there is a value here at index 1, append that. And you can see we're kind of building up the string, so now it's been appended. Result is equal to Church of Turing plus is plus 200. And now all we need to do is append this last string. So if we go in, because the index is 2, it says this is the current string we're interacting with. So we append that to the end. And now we do a little check. It says if values I, but because we've ran out of values, we just skip over it entirely. We've got nothing left to append. And then we return the result. At the end, we have pretty much identically the string that we had in the last example. So at this point, you're probably wondering, that was a whole lot of work. It seemed a lot more complicated just to achieve the same thing. But you can do a lot more sophisticated stuff with tag template literals. I'll show you this next example. So here we're defining a little SQL domain-specific language. So I have this function called quoteString that just takes a value, and it sees if a value equals, or if the type of a value is a string, then just surround that string with quotation marks. If you've ever used SQL, you know that, numbers are just numbers, but if you want to include a string, you have to surround it with quotes, or these little quote. And then moving on, I'll explain this in a second, but it's pretty much identically the function that you saw in the last example. The only difference is, instead of appending the value directly, we append the value after it's been quoted, if that makes sense. But it's pretty much exactly the same thing. And then now here, we set up our table name. We say we want to access the users table, we want to access the username column, and we want to search for Church of Turing. And now we can build this SQL query, just doing something like select star from table name where column equals search term. And if we console log that now, you can see that it generates the text and it surrounds these strings with quotes, which is what we wanted all along. Now, I don't suggest you use this in like a production, like, you don't roll your own queries like this. I'm sure it's vulnerable to all sorts of security attacks. I'm just trying to show you and illustrate what you can do with type template literals, because you can make some really sophisticated domain-specific languages, but they're not something that should be used lightly. You know, be very careful, especially with untrusted user input. Anyway, moving on. The next thing I wanted to talk about were the promise static methods. So the promise class gives 4 static functions to help with async programming, and they all operate on arrays of promises. So you might have used promises before, you might have used async await, things like that, but you can also use promise.all, promise.allSettled, promise.any, and promise.race. And I'll show you what these do in a second. So here's our little code example. I've got a function here that generates a random number between a min and a max, and we use this for the number of milliseconds that we want our promise to wait for. And then I have a little function here that creates a promise. It generates this random number, and then it resolves the promise after a random amount of time. Then once we move to main, we call this big main function. And our first example that I want to use is promise.all. So promise.all fulfills when all of the promises fulfill and rejects when any of them reject. So all of the promises in the array of promises need to fulfill, or else it'll just reject entirely. This piece of code here just says create an array of length 5 filled with random promises that all resolve at different times between 200 milliseconds and 1000 milliseconds. So this will resolve because none of these promises are actually going to reject in this example. And then if we look at all settled, this fulfills when all of the promises settle, and by settle it means it can either be rejected or fulfilled. It doesn't have to necessarily just be fulfilled like all expects. And then moving on, we can do promise.any, and this fulfills when any of the promises fulfill and rejects when all of the promises reject. So if you have an array of promises, it's really just looking if any single promise in that actually fulfills. And then race just returns a promise whenever any of the promises settle. It tries to do the fastest one effectively. That's why it's called race. You're trying to race to get one to settle as soon as possible. And then if we just console log these results, all returns the array of the milliseconds that it took. So 734, 835, and so on. This is all of the promises in the array resolving. All settled does effectively the same thing, except it includes the status, because now it can be rejected and so on. And it also includes the value. Any just returns the first function that fulfills, or the first promise that fulfills, like we talked up here. And race just returns the fastest one that settles. So these are really useful. Sometimes you'll want to get, say for instance, you have an array of IDs and you want to make requests to a HTTP server that returns, data objects for them. So you want to turn that array of IDs into an array of promises, and then you want all of those promises to settle effectively. So these are really useful methods. I've used promise.all quite a lot. I've never really used any of these other ones, like promise.any or promise.allSettled, but I'm sure they'll be useful at some point. Anyway, moving on. The next thing I wanted to talk about was the intl object. The intl object contains the internationalisation API. And this is really useful for parsing and formatting numbers between different languages, parsing and formatting dates, parsing and formatting times, and translating currencies, and so much more. I'm really only scratching the surface of what the intl object can actually do. I'll include again in the description all of the links to the documentation so that you can explore yourself. But just a few examples here. Let's look at printing dates. So I'm creating a new date, and I'm saying format it English Great Britain format. which is day, month, year. And then in this new example, I'm saying formatted English US, which is month, day, year. And then this next example, I'm saying formatted like Korean, which is year dot month dot day, which is quite strange. I've never seen this format before, but it's very interesting. Another example could be printing numbers. So I have this large number, 345,763, with a decimal point. And depending on your country, this will be formatted quite differently. So if I format it like in Great Britain, which I'm familiar with, it'll add a comma and then it'll add a decimal point. But for Germany, it'll do exactly the opposite. It'll add a decimal point and then a comma, which is quite confusing. And then for Egyptian Arabic, it'll return this, which I have no idea if it's actually correct or what that means, but I'm taking it as truth. Another neat thing that it can do is translating currency display names. So let's look at this example. I'm saying, give me the display names in English for currencies. And I want to see what the display name of the USD is, and it'll say it's the US dollar. Or what's the display name of GBP, which is British pound. Or what's the display name of THB, which is the Thai baht. And this is really useful because this can go from like many languages. So here's another example. I want to get the display names of currencies in Korean. So I'm saying, give me the display names in Korean of currencies. And I want to say, what's the display name of the United States dollar in Korean? It'll return that string for me. And for the Great British Pound, it'll return a string, and for the Thai baht, it'll return another string as well. I can't read Korean, so I'm taking this as truth, but it's pretty neat that you can do this at all for practically free. And the last thing that I wanted to talk about was the Web Speech API. So many people don't know about the Web Speech API, but the browser has an API for doing text-to-speech and also doing speech recognition. Now, one thing that's worth noting is this is only a browser API, and I think it's available on most of the popular browsers, but it's not available in Node.js or Dino, for example. If we look at the Web Speech API, it's really easy to start doing text-to-speech. Let me close that. It's really easy to start doing text-to-speech, so all I have to do is define a function called say, and it takes the text, the voice, the rate, the pitch, and the volume. And it starts setting these values. So it's setting the text, setting the pitch, setting the volume, setting the rate, and setting the voice. Then I just ask the window to speak this utterance. And then I call it down here. And we can see the defaults. The rate is between 0.1 and 10. The pitch is between 0 and 2. And the volume is between 0 and 1, which I've slightly lowered here. I'll actually show a little example of it in the console. So let me go here. Let me go to the console. And I will copy this text. So if we do this, maybe I'll turn the volume up slightly.
Hi, how are you doing?
So that says, hi, how are you doing? And then if I just want to use, the say function again, let me just pull it back. I can change the voices. So I think there's something like 22 voices. You can have a play about. So I'm only using the second one here, but if I do something like the 10th voice, and I want the rate to be slightly lower, so maybe 0.8, the pitch to be slightly higher, and the volume to be slightly higher, it will return, let me just change the text actually, I am doing well. Thank you. And then if I enter this,
I am doing well, thank you.
Okay, that was interesting. I have no idea what voice that was. Many of the voices are to kind of target international language speakers, so there's like a Polish voice or an Indian voice and so on. But it's really handy. I've used it a few times for a few different projects. One of the one I did was for Discord. I would check for incoming messages and then text to speech them so that I could hear the Discord messages while I was doing something else. Okay, moving on. The other thing that I wanted to... Oh, this just goes through the setting of the properties. And the other thing that I wanted to show was speech recognition. So MDN have threw together this live demo, which I'm going to open now. And this will change color depending on what you say. So if I click this and I say tan, oh, it recognized it, but it wasn't a valid value. So I'll do it again. Tan. Tomato. Olive. Of course, it doesn't recognize my accent sometimes, so it's a bit hit or miss, but let me try it again. Cyan. Indigo. Lime. And so on. It actually works pretty well. I was very surprised, especially because my accent can be very picky sometimes. So if I just skip through back to the end of this, skip through everything, that speech recognition API could be pretty handy in the future. I don't know what I would use it for. I've had an idea of a game that maybe you could do some speech recognition and play about with it that way, but I'm not sure myself. So this is the end of the video. I just wanted to say thank you. I know not all of these were stuff that you absolutely need to know, but hopefully I've exposed you to a new idea that maybe you could use in a future project. I'll include all the links to the documentation in the description below. If you enjoyed if you enjoyed this presentation or what I threw together, please like, comment, subscribe, or if you have any questions, please leave them in the comments below. Thank you so much. Have a good day.